Let's
We're good. Thinking about that.
Ready? Skeletal system.
skeletal structure.
Bones. Skeleton.
Okay, good. Okay, guys and girls. Bone development. The other day in class, we started talking about some of the functions of bone. We said the bone has 5 main functions. There are 5 things that your skeletal system does for your body. You remember this discussion? Can you name one for me? Does someone name one? Tiffany? Okay, the bone system allows for movement. Let's write some of these down. Okay, number 1, it allows for movement. Okay, what else does the skeletal system do for our body? Yes? Oh, wonderful. Storage. Storage of minerals. What are some minerals that we store, by the way, in our skeletal system? Some useful minerals and things we store. Name one? Calcium. Okay, good. Name another one? Yeah, good. Minerals. That's great. Well, we got calcium. Is there another one that you remember our discussion with?
Vitamins.
Vitamins and minerals are 2 different things. We have a group that's going to tell us all about that in a couple of weeks. Okay, we mentioned calcium, silicon, and we also mentioned phosphorus are some things that we mentioned in class. Okay, let's go on. Number 3, what's the third thing that the skeletal system does for us? Scott?
Supports the body.
It does. It supports, it adds structure to the body. It supports. Remember the example we gave in class the other day. Those of you that have been camping before, right? We had the tent laying out and it's all ready to go. We're gone camping, but we forgot the supports. We forgot the little fiberglass or the aluminum poles that hold it up. How successful are we going to be in making the tent? Other than if you go out and get some sticks out of the woods, right? If you forgot your supports, what's the tent going to do? It's going to lay there. We can understand or we can imagine what our bodies would look like without the skeletal system. How much we can get done. Yes, Tiffany. Wonderful answer. One of the 2 types of blood cells that we know that it makes. Kayla? Yeah? What do red blood cells do for you, Kayla? What do we need red blood cells for? Can you tell me? Wonderful answer. Transports oxygen. Even transports carbon dioxide back out of the body, right? Good. Transports gases. What do white blood cells do for us? What do white blood cells do? Good.
They help clear out your body from all bacteria and stuff.
Very nice answer. Very nice. It helps clean the body, keeps it cleaned out. Bacteria infections, things like that. Okay, number 5. What's the 5th thing that the skeletal system is going to do for us, Brad?
It protects us.
Okay, good. It protects us. How does it protect us? How does the skeletal system protect us, Daniel?
It protects your organs by, because it's hard and
Okay, give me an example of an organ that's protected by the skeletal system. Go ahead, name one. Okay, the heart's protected by the skeletal system. Name another one. Okay, the lungs are protected. Never mind. What? Okay, your stomach is down here, okay, but it is semi-protected by the rib cage. Go ahead. Okay, the brain's another really important that's protected. Okay, let's stop there. Okay, guys and girls, these are the 5 functions of the skeletal system. Now, what we need to do is we need to talk about the beginnings of the developing of the bone itself. Now, when you guys and girls, when we were all born, when we first came into this world, our bones were not exactly the way they are now. Anybody have any idea of what our bones were probably like when we were born? Gary?
Smaller.
Okay, smaller. That's true. Much smaller. Donna? Excuse me? You know, we say fragile. We say that the bones of the baby are more fragile. But you know, that's really not true. That's really, really not true. And there's a reason for that. That's where we're headed. Go ahead. Okay, you hear what he said? Say it again. They're flexible, they've been more easy. You said that they were surrounded by... Okay, he's almost there. They are flexible and they do bend more easily. But are they surrounded by more cartilage? I think the proper way to say it is what? They are. They are mainly cartilage. The bones of a young child's body are mainly made up of cartilage. Matter of fact, the way the bones harden or solidify themselves is by adding what to them? And you guys have told me already those things. Okay, good. Say it again. Okay, calcium. Say it again. Minerals, good. Calcium, minerals, phosphorus, silicon, all those things added. We know that if we add minerals to the bones, just like we do if we add minerals to the rocks, what's going to happen to the bones? Say it again. They're gonna harden. That's why rocks are so hard, is because they have minerals in it. Put your chair down. Put your break on chair. Okay, the rocks are so hard because of the mineral content in them, and your bones are so hard because of the mineral content also. Guys and girls, if we took a bone and we boiled it, or leached out, or pulled out the minerals out of the bone, what could we do with the bone? If it isn't brittle or hard, what could we do? Yeah. Guys and girls, we could take the bone and we could tie it into a knot and it wouldn't break. Whoa. We could tie it to a knot and it wouldn't break. So, developing bones, most of us start out, all little babies, start out with cartilage. Mostly the body's made up of cartilage. Now, where can I find cartilage on my body? How can I see an example of what cartilage is truly like? Okay, everybody go. Get yours. Okay, right here, where else? Where else? Go. Your nose. Tip of your nose. Do this. Tell me something about cartilage now. Tell me something about cartilage. What do you know about cartilage now? Go. Okay, it's fine. Okay, she said it's bendable. Anything that hurts is bendable? Yeah? Yeah, it hurts when you pull it. Go ahead. Softer than bone, bendable. It's very flexible and bendable. It's squishy. Guys and girls, you know what I think it's amazing though? Even though it is softer and bendable, it does still support. It does still hold up and support. It has shape. It supports the muscle or the flesh around it. So cartilage does have some neat characteristics. If you want to see cartilage up close and personal, next time you eat chicken or chicken breast, go down to the very tip of the breast there, and you got that white rubbery stuff. Ooh, yeah, that's it. That's the cartilage. Ooh's the cartilage. Now, let's talk about a developed bone or the bone structure itself. Now, what I've got up here is an incredible, probably a world-famous picture of a bone that I drew up there myself. I want you to know I did this myself. I did. Okay. Thank you. Throw money now. Okay, here we go. Now, let's talk about some of the different structures. First of all, there's the white out here that surrounds the outside of the bone. It tends to be a sleeve that surrounds the bone. What do we call this sleeve? Does anybody look ahead in their book? No. No. Oh. Everybody say the word. Just a minute. Everybody say the word periosteum. One more time. Periosteum. Periosteum is a protective sleeve that surrounds the outside of the bone. So if we look over here, by the way, what's the longest bone on the human skeleton? What is it?
You may want to change it.
Yeah, the femur. They're good. So if I take this femur or any bone here, and I look at this bone right here, if I look at this bone is going to be surrounded by a sleeve or a membrane that's called the periosteum. Now, what's the purpose, or what do you think we can get out of the periosteum? What do you think the purpose of that bone structure could be? Why would you want a sleeve around this bone? Oh. Very nice answer. Good more support. Name something else. What do you think? Take your guesses.
Protected.
Good answer.
Oh, it might not hurt.
Okay, good. Protection, support are the two things I keep hearing. Let's add a couple more things to it. Ready? The periosteum allows food, oxygen, and nutrients to get to the bone by traveling underneath itself. It allows it to get to the bone. Let's just say, let's say that Eric goes out for track. Let's say Eric goes out for track. He becomes this great long jumper, and during practice, he's running down the runway. He gets to the board. He's counting his steps. He's going 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, off the board. Big hit, boy. Boom. He's up in the air. He's driving forward. He lands. All of a sudden, he realizes, the takeoff. He's got what's called a hairline fracture. Okay, he's got a crack that runs down the face of the bone. It's a little crack. Now, that periosteum is going to be really important because the periosteum is a protective sleeve that not only protects and supports, but it's also going to allow nutrients and calcium and other repair needed material to get to that area. It has growth cells in it that's going to allow the growth and repair of that area. It's there for development and also there for repair, not just support and not just to protect, but it's there for repair and growth. The periosteum is really important, especially at your age, for the growth that you guys are going to go through. As your bones get longer, you guys get bigger. Let's go down to the next one. The yellow inside. We call this hard bone, but the word that your book's going to use is called compact bone. Compact bone. Take a guess. What do you think is going to be found in a compact bone? You've already told me again today what you think bone is made out of, or some things that are found in bone. What's going to make this bone hard? What is it that's found inside this compact bone layer? Go ahead, Scott.
Calcium?
Good, calcium. There's the number one right there. Name it. Okay, marrow, we'll talk about that in a minute. Hold that thought. Anybody else? I think in general, the ballpark idea would be all those minerals that we talked about. Elastic fibers, all the minerals that make up the bone. The minerals are found in the compact bone. That's the hardness of the bone. By the way, is the bone living or non-living? In other words, this hard let's talk about the compact bone. This really, really hard stuff. Is that living or non-living? I'm sorry, what? You think compact bone's living? No? How many say no? 1, 2, 3. How many say yes, it's living? Actually, it is living. You know, and I've got some Microsoft slides. I hope that by the end of the class period, if we have time, I have some slides already for you guys to see some actual bone cells. But bone cells are living because we know the bones grow, don't they? We know the bones repair themselves, right? Okay, so we have to have living cells there to make this happen. Okay, this is called compact bone. Let's go down a little bit further here. Let's start at the very top here. There's the end of the bone right here, the very cap of the bone. You know, where all the big structure, where all the support's going to be, where all this pressure is going to be when you're walking and jumping and running, and it's the thickest part of the bone. Anybody know what this part's called? I like that. You said it soft, but you're absolutely right. Spongy bone. Spongy bone. Guys and girls, spongy bone, because it's made just like, it looks and feels just like a sponge. No, it doesn't feel like a sponge. It looks a little bit like it, but it doesn't feel like a sponge. See, here's why. Look at the skeletal system here. Just think about this. In comparison to the rest of the body, this is pretty heavy, isn't it? I mean, it's all this bone stuff right here. You think that the body's, a lot of the body's made up of bone. It's not true. It's not true at all. All the space this bone takes up and all the hardness there and everything combined. This 200 is what? How many bones in the average? You guys told me 206 the other day. 206 bones. And in you guys, there's even more than there is in me. I have about 206. You got more than I do. You know why? Well, because you're younger. Bless you. Oh, okay. Yeah, you got more than I do. Because as you're younger, your bones are separated, and then eventually, over time, as you get older, then you get to fuse together. Some of the bones will eventually become one bone. Matter of fact, if I'm an archaeologist, and I'm on this archaeological dig, and I find this skeletal remain of this body, I can tell how old the body is, and what sex it is also, by the structure of the bone, but I can also tell by whether or not certain areas of the body are fused or brought together. I can look, for instance, at the sternum, the breastplate, and the breastplate on a young boy or girl and a baby is separated into 3 separate sections. But on an older person, like, woo,